Okay, in the fourth problem of our online lesson number 2, labor supply, we're going to consider non-monetary factors that affect the decision to work. To do the analysis, we first want to look at what happens when a monetary factor, like a toll, is added to the commute of a worker's decision. Okay. Now, suppose that a worker's commute is less than a mile, but it involves a highway that is about to start charging a toll. The proposed tolls come in a variety of forms. The one the worker ultimately chooses is a weekly pass that will cost her $118 per week. So her toll right now is 0, but it will increase to $118. Since there is no other way for her, the person, to get to their job, she will have to pay it to get to work. That will happen. What will happen to hours of work as a result of this increase in commuting cost? Now, initially, when there is no toll, so over here I'm going to write T, little t for toll, and it's 0. The worker collects a Navy pension, non-labor income of $310 a week. Her hourly wage is $18 with her current employer, and she can devote at most 80 hours to either work, leisure, or commuting, right? In this case here, where there's just she lives next to her work, she'll just have to pay $1 cost for commuting. In the next version of the problem, in part B, we're going to look at what happens when the firm moves, and now she's going to drive a distance to her employer. Okay. So we got all that basic information down. Here is our consumption leisure model. The optimal solution is this point. This is the indifference curve, the person's indifference curve. Utility is constant along the indifference curve. Here's the person's budget line, right? That's the person's budget line. And the budget line has a constant slope equal to her wage, and her wage is 18. Her indifference curve has a decreasing slope. It decreases in absolute value from a very high level to a very low level. And that's because here leisure is scarce, but consumption is not. So in order for her to want to have an additional hour of leisure, she's willing to give up a lot of consumption to get that extra hour of leisure, because leisure is scarce and consumption is not. Down here, the opposite is true. Consumption is not, consumption is scarce. Leisure is super abundant. So when she wants one more unit of leisure, she doesn't have to give up very much consumption to get that additional hour of leisure, because again, leisure is super abundant and consumption is not. So that's why the curve bows, right? All right, so before the toll is imposed, the worker's optimal solution is the point on the indifference curve that is just changed to the budget line. At this point, the worker chooses 48.6 hours of leisure, right? 48.6 hours of leisure per week. If her leisure is 48.6, then her hours of work are going to be the time constraint minus her leisure. So she's going to work 31.4 hours a week. Okay, so now we got to form the budget constraint, right? And the budget constraint is consumer goods and services, dollars of consumer goods and services that she purchases, plus leisure hours she wants each week at a price of her hourly work wage, right, which happens to be 18. On the right-hand side, this is the value of her time, and this is her allowance, her non-labor income. We plug in 18 for the wage. We plug again 18 for the wage. We replace T with the time constraint, 80 hours a week, and then replace A with 310. When we put these two together, we get 1750, right? So down here, I'm going to write consumption, right, equal to, oh, and also we got to subtract off T here, right? But T 0, so that's why it's not on here, right? I went back and added this. I added the equation to add the toll, right? So the toll here is 0, right? So the toll initially is 0. Okay, so the budget constraint starts out at W times L, right? And then that equals W times capital T plus the allowance minus the fixed toll each week, right? Now I want to solve this for C, right? So all I have to do to solve this for C is to subtract this from both sides of the equation. Okay. Now if I undefine L, what's going to happen here is we can graph. Let me do this too. I want to limit L. L is at most 80 and at minimum 0. So in order to limit L here explicitly, I do a squiggly bracket, 0 less than or equal to L less than or equal to 80, right? And then I can hide that. Okay, I'm going to hide it by stretching this back over here. Okay, so I can graph that because this right here is some number. In my case, it's 1750, right? So this is just 1750, and this right here is 18, right? So we can graph that over here. I'm going to scroll this out until we get to, let me also get rid of this here. Well, that'll hide once I add. Okay, so there's my 80, right? Now, my intercept, my y-intercept's got to be, I'm gonna stretch this so the y values go from 0 to 2000. So let me click on this. I'm going to change this to 2000 here. And then I can just pull this down here like that, right? Okay. So that's my consumption function here, right? At 0 hours of leisure, my consumption is 1750, which agrees with this here, right? So if that's 0, and consumption is 1750. If leisure is 80 times 18 subtracted from 1750, well, that's equal to what? That's equal to 310. 310 is my allowance, right? My weekly allowance. So that's the graph of the consumption function, right? Okay, but here leisure is what? Leisure is 48.6. So right here, I'm going to type L equal to 48.6. I'm going to match it with right here, right? Because at the optimal solution, the person is choosing 48.6 hours of leisure, right? And then that tells me 48.6 can be plugged into my consumption function, and it should be some value less than 1,000, right? And it is. It's $875.20. So what Desmos does is after it substitutes all these values in, right, it's going to substitute the 48.6 right there, right? And so consumption is $875.20. Okay. Now, at the tangency point, the slope of the indifference curve equals the slope of the budget line. We already talked about that, right? So if I zoom in right here, the indifference curve is going to look like the budget line, right? They're both going to have the same slope when you focus in on here. They don't have the same slope at this level of leisure, and they don't have the same level of slope at this level of leisure. But at this level of leisure, they have the same slope. And that slope is equal to the wage, 18. So the slope of the budget line is 18 at that point. The slope of the indifference curve is called the marginal rate of substitution. At the tangency point, again, the slopes of the two are the same, right? Because we can focus in and that curve looks like a flat line. And it equals a negative 18, right? Now, as you move down along the indifference curve, utility does what? As you move down along this curve, right, utility remains constant, but the slope is getting closer and closer and closer to zero, right? As you move up along it, the slope is getting increasingly negative, right? So as you move down along it, utility remains constant, and the MRS gets closer to zero, right? Now, the imposition of a toll, right? Let's go back here. Let's undefine L real quick. Bring back our consumption function. Right? Let's bring back our consumption function. We want to find out what happens when we impose this toll. So if we impose this toll, and my toll was $118, I think, right? When we impose this toll, mine's 118. I'm going to replace the zero that the toll is equal to 118. And what happened to my budget line? Okay, so there it is when the toll is zero. And then when I'm going to put my cursor here, my mouse pointer, and I'm going to replace the zero with the new toll. It caused the budget line to shift inward, right? It caused the budget line to parallel shift inward. The slope didn't change, but the intercept did, right? This went from this right here was zero. Now it's 118. So it's subtracting, given a level of leisure, it's subtracting from the height the amount of the toll, right? So the budget line shifts in. Budget line downward. The imposition of the toll shifts the budget line downward by the amount of the toll, right? And the toll is 118. So you can see that here, the budget line shifts inward by the amount of the toll, right? Downward by the amount of the toll. Resulting in this new budget line, right? This new budget line. So the new intercept is 1632. We can verify that by clicking right here, right? So the new intercept is in fact 1632. The slope is still 18. We haven't changed the slope, right? But the intercept is 1632. This results in a new optimal solution. Okay, so we can't afford, none of the points on the blue indifference curve are now affordable, right? They were affordable on the old budget line, but on the new budget line, none of them are affordable. So what's going to happen is utility is going to be lower, right? So this causes her utility to decline. Her utility will decrease, right? Until the resulting indifference curve is just tangent to the new budget line. And that happens at this point where leisure is 45.3, right? So at this new tangency point, the worker chooses 45.3 hours of leisure, right? So 45.3 hours of leisure. Right, that results in her working 34.7 hours, right? So her hours of work went up, right, from what it was before, 31.4, to what it is now, 34.7, right? And her hours of leisure went down. It went down from 48.6 to 45.3. So hours of leisure went down from 48.6 to 45.3. Also, consumption declined, right? Just consumption declined. Consumption was 875, right? Roughly. Now consumption is $816, right? I'm getting that from my consumption function over here in Desmos, right? Okay, now in part B, we're assuming the same initial conditions, right? We're gonna have to reset this. The toll is zero. The toll is zero. And the worker is still collecting $310 a week from her Navy pension. The wage is still $18. I'm going to get rid of the leisure here. Her hours of work, the amount of time she can spend toward work, leisure, commuting is still 80, right? Still 80. Now, instead of assuming that there's a new toll, we're going to look at the situation where all of a sudden her employer is going to move, right? Her employer is going to move. Because, maybe they got a better property tax bill in the next town, right? Maybe they got their top property taxes eliminated as an economic incentive for a couple of years, right? So they're going to take advantage of that and move, right? Okay, so presently her commute is zero, but the relocation of the factory to another town will add 19 hours to her weekly commute. What will happen to the hours the worker will spend on the job as a result of this increase in her commute? So the initial condition is still the same as it was, right? The consumption function is just like it was before. 1750 minus 18L, right? And the worker chooses 48.6 hours of leisure. The worker's going to supply 31.4 hours of labor. The budget line is identical to the budget line in part A. So the worker consumes what? The toll is set equal to zero. Leisure is 48.6. So back here in scenario B, or the initial scenario, 48.6. Consumer goods are $875.20, just like we have over here, right? Okay, so we're back to this original point here. Right? Now, after the firm moves to its new location, the worker's weekly commute increases from 0 to 19 hours. What is that going to do? Well, essentially what that does is it subtracts, right? Those hours to commute are going to come from the time component, because remember the time component, what that is. The worker has 80 hours and she can devote that to leisure, work, or commuting. Before, her commute was 0. Now our commute is not 0, right? So moving to the new location adds 19 hours a week to her commute. So what's going to happen here is now 61 is the maximum, because mine is 19, right? It's a 19-hour commute per week, right? Instead of 80 here as my maximum amount of leisure that she could have, it's now 61. Okay. Now, what does that do to the budget line? Let's look at what it does to the budget line. So before the company moves, the budget line's there, right? So this point here represents her endowment point. I'm going to make this T. I'll make that T right there. There we go. Okay. So the leisure amount is still bound between 0 and T, right? I just, instead of writing 80 here, I put T there, right? Okay. So at this point here, it's called the endowment point. If she uses all of her time for leisure, the most she can spend on consumer goods is $310. And that was the weekly allowance she's getting, right? So yeah. All right. So when all of a sudden the company moves and her commute is now 19 hours more per week, what happens to the budget constraint? It didn't shift down, it shifted to the left, right? It shifted to the left. And now her endowment point, the height of it's still $310, right? Because that's how much she gets from the Navy in non-labor earnings each week from her pension. But now the time available for commuting has eaten into that time that she had budgeted for commuting, leisure, and labor, right? So the whole line shifts to the left, right? So that shifts her budget line leftward, right? By 19 hours. Okay, so her budget line shifts leftward. It shifts leftward by 19 hours, right? This right here is 61 hours, right? This here is 80 hours. And the difference in those two sets of hours, the horizontal difference between these 2 points is 19 hours. That's the additional commute that she has, right? Now, before the firm moves, the worker's optimal solution, oh, we already did that, sorry. Now, this results in a new optimal solution. So what's going to happen here, again, what's going to happen is none of the points on this indifference curve are affordable on this new budget line. So what's going to happen is we're going to draw a new indifference curve in here that's going to represent less utility. So our utility's got to decrease, right? Let me hit enter. Now at this new optimal point, her leisure is 39.1. Her leisure is 39.1, right? So let's go back over here. So her leisure now, with a 19-hour commute added to her work week, her leisure is 39.1. The hours she works each week is only 21.9. Whoop, 21.9. Her consumption with the 19 hours added to her commute, right? Her consumption is only $704.20. So consumption took a big hit, right? It was $875.20. Now it's $704.20, right? Okay, so her hours worked actually went down, right? So her hours worked were 31.4, and now it's only 21.9. Her leisure went from 48.6 down to 39.1. So both her leisure and her hours work declined. Up here, when it was just a monetary toll, her leisure was 48.6. When she had to pay that monetary toll, her leisure dropped to 45.3. Her hours worked, though, did the opposite. Her hours worked went from 31.4 to 34.7. So the commute really cuts into her hours worked, right? So compare the effects of the types of commuting on the worker. The toll and the increase in the commute decreases the worker's leisure hours in scenario A. The worker spends $118 on tolls. her income declines by what? So this is with the toll. Her income declined by what? Her income before the toll was 816. After the toll's instituted, her income, her income increases. Whoops, I'm in the wrong one. Here it is. I got to go back up here. So in scenario A, her income was originally $875.20. When the toll is instituted, her income drops to $816.60. So her income drops by $58.60 when the toll is introduced, right? Whoops, this is my cursor was stuck 875.2, right? Okay, so her income drops $875.20 from $875.20 to $816.60, right? Her hours worked, it was 31.4. It was 31.4, her hours worked. Now her hours worked is 34.7. So her hours worked increased by 3.3 hours. So her hours worked increases by 3.3 hours. Her income declines by $58.60. And that's with the toll, right? That's with the toll. Okay. In scenario B, the worker's commute increases by 19 hours, right? Her income declines. Her income after the company moves and her commute gets bigger, her income is $704.20. Her income was before the commute $875.20, right? So this is what it was before the commute, before the toll. This is after the commute is increased from 0 hours to 19 hours because the company moves, right? Her hours worked were 31.4. Now her hours worked is only 21.9 because of the commute. So a non-monetary factor like commute time all of a sudden jumping 19 hours, that results in her hours worked decreasing. She decreases her work effort by 9.5 hours. And her income declines by 171. So the commute has a real negative impact on her. It lowers her utility more than it would have if it was just a toll, right? Her utility is shifted way in. See that? Her utility is shifted way in relative to up here. This is a smaller change in utility. This is a huge hit to utility, right? Schultz took a huge hit to her income, right? So that's why people say time is money.